Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to practice our exponent rules. Now, before we begin, let's just do a quick review of the rules of exponents. So the first one is the zero power rule, basically, or if you have zero exponents. If you take a number a and you raise it to the zero power, you will get 1 as long as this base a is not 0. 0 to the 0 is undefined. But if a is any other number, then a to the 0 is 1. Now, if you have a negative exponent, a to some number negative n, that is the same as 1 over a to the positive n. Okay? The product rule for exponents, if you take two exponential expressions and they have the same base, so notice that this a here and here are the same, okay? Then a to the m times a to the n, you can simplify that as a to the m plus n. Now, for the quotient rule, if you have a division of exponential expressions, and again, if the base is the same, right? A here, right? A to the m divided by a to the n, you simply subtract exponents. So you get a to the m minus n. We have called the power rule here. If you take a to the m and you raise that exponential expression, so you raise the whole thing to the nth power, then you simply multiply the exponents. And I'll point out here, this would also be the same as a to the nth power raised to the mth power, like that, which can be a useful fact. If you take a power of a product, so you take a product like a times b and you raise that to the nth power, you simply are going to raise each factor in here to the nth power. So in other words, a times b to the nth power is a to the n times b to the n. And it's the same thing for quotients. My apologies, this should be a b right here. Okay, if you have a over b to the nth power, that's the same as a to the n divided by b to the n. Example 1, simplify, express the answer with no negative exponents. So remember, when you're doing these, it's going to be really important to remember your order of operations rules, which is PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. The important one is the first two, really. It's parentheses and exponents. So we want to simplify things in parentheses first. Now, anyway, for this one, there's not a lot to do here. So the first thing here is -3 squared. So notice there's two parts to this problem. You have -3 squared, and you also have -5 quantity squared. So this -5 is inside the parentheses. And what that means is that the number -5 is being squared, right? So what is -5 squared? It's -5 times -5. And since a negative times a negative is a positive, then what you get here is you get positive 25. Now, because multiplication happens after exponents, when you see -3 squared and it's not in parentheses, there's no parentheses there, what that means is you multiply the negative sign after you square. See, in here, the -5 is in parentheses, so you're doing parentheses and then exponents. So this is not positive 9, it's -9, because it's -1 times 3 squared. So what you get here is you get -9. And so we get -9 times 25, which is, of course, going to be -225. Example 2. All right, there's a little bit more to do in this problem. So remember PEMDAS. So the first thing we do is we want to see, can we simplify anything inside the parentheses? And the answer is we can't. So we have this squared here, though. And so we're going to use that rule where we raise a product to a power. And what we're going to do is we identify what are our factors in here. We have -3, x to the 6th, and y. I need to square each one of those. So I'm going to get -3 squared, x to the 6th squared, and then y squared. Okay. And now over here, you notice there's no exponent here. There's nothing there. So really, you don't have to do anything. You just have these three factors. But I'm going to write them down. So we have -4 times x cubed times y squared. All right, now back over on the left, -3 squared is +9. Okay, x to the 6th squared, that would be x to the 6 times 2. So that's going to be x to the 12th. And then we have y squared here. And then over here we still have times -4 times x cubed times y squared. Now we want to do is just pair up the sort of factors that have the same base. So we have 9, we have these numbers. So 9 times -4, that's -36. Okay. We have x to the 12th and then x cubed. So I'm pairing those up because they have the same base. The base is x. So x to the 12th times x cubed, the way we simplify that is by adding, since we're multiplying this times this, we're going to add the exponent. So it's x to the 12 plus 3. It's going to be x to the 15th power. Okay. And then finally, the last sort of factor we have is a y squared and a y squared. These have the same base. The base is y for both. So it's going to be y to the 2 plus 2. It's going to be y to the 4th. And now that's completely simplified. Okay. All right. We want to simplify this and express the answer with no negative exponents. I'm going to write down our order of operations over here again, just to be clear. P, E, M, D, A, S, right? So again, I want to simplify anything I can in the parentheses first. But basically, notice since division, right, comes after all the other ones, parentheses and exponents, we're going to simplify this up here in the numerator, simplify the denominator, and then we'll do our division. All right, so first thing first, I can actually simplify this. This y to the 0 power is just 1. So this is actually just going to be 2x cubed times 1, but I don't have to write times 1, cubed. And in the denominator, there's nothing in these parentheses that we can simplify. So it's just 4x to the 4th times y cubed, and then we square it. Now, again, each factor in here, I'm going to raise that to the 3rd power. So what we get then is we're going to get 2 cubed. Let me write that a little neater. 2 cubed, and then x cubed, cubed. And in the denominator, I have 3 factors, right? 4x to the 4th, y cubed. So I'm going to get 4 cubed, or sorry, 4 squared. I'm going to square each one. So we're going to get 4 squared times x to the 4th squared, and then y cubed squared. So now if I simplify that, I'm going to get 2 cubed is 8. And again, when you have x cubed cubed, you're going to multiply the exponents. It's going to be x to the 3 times 3, x to the 9th. Okay. Down here, I'm going to have 16 is 4 squared. X to the 4th, when I square that, I multiply the exponents. It's going to be x to the 8th power. Okay. And then finally, y cubed squared, I'm going to take y to the 3 times 2, so y to the 6th power. And now I need to simplify this. So it's the numerator is completely simplified. The denominator is completely simplified. So the last thing to do is divide. So again, 8 over 16 is going to be simplified into 1/2. Now you have x to the 9th divided by x to the 8th, right? You have an x to the 9th in the numerator and an x to the 8th in the denominator. So the way you're going to simplify this is by subtracting. So you're going to get x to the 9 minus 8, which is 1. I'm not going to write it to the 1st power. And then down here, you're going to have 2y to the 6th. Okay. And that's it. So notice, again, you can write up here like x to the 9 minus 8. Okay. If that had been a negative number when you did that subtraction, you would then flip the factor into the denominator if it had a negative exponent, and then change the sign, right? Because again, we want to express our answer with no negative exponents, but we didn't end up with any negative exponents here. All right, example 4. So there are no parentheses in this one, so this one's actually a little bit easier to simplify. So what we can do here is really just, again, since we have a quotient here, we're just going to take x to the -2, right, divided by x to the -5th. We can use the quotient rule here. It's going to be x to the -2 minus x to the -5th. So what it's going to look like here is, what you can do really is write this out as essentially three parts. The numerical factors, so negative 12 over 3, and then x to the negative 2 over x to the negative 5, and then y to the fourth over y to the negative 2. Now, negative 12 over 3 becomes negative 4. X to the negative 2 divided by x to the negative fifth, this is going to become x to the negative 2 minus negative 5. And then y to the fourth divided by y to the negative 2 will become y to the 4 minus negative 2. And now we simplify this. So we get negative 4. Negative 2 minus negative 5 is going to be negative 2 plus 5. So that'll be x cubed. Okay. And then y to the negative 2 minus negative 2 is going to be y to the 4 plus 2, or y to the 6th. And we're done, right? We have no negative exponents here, so there's nothing left to do. Example 5. So the next thing we want to do, or the first thing we want to do in this example, again, is simplify anything inside of the parentheses. Since again, parentheses is the first step in order of operations. So what we get here, so I'm going to do this kind of like we did last problem. So it's going to get 3 over 2 times, it's going to be m squared. There's no m factors in the denominator, so there's nothing to do there. And then times n to the fifth over n to the negative 3. We want to take that to the negative 2 power. So we're going to get, if we simplify this, we're going to get 3m squared. N to the fifth divided by n to the negative 3 is going to be n to the 5 minus negative 3, or n to the 8th power. And then that'll all be over 2. And now that's to the negative 2 power. So now we raise every single factor to negative 2. So what that gives us now is 3 to the negative 2, m squared to the negative 2, n to the 8th to the negative 2, and then in the denominator, 2 to the negative 2. Okay. So what we can do is any factor that's any exponent that's negative, we can simply change it from the numerator to the denominator, or vice versa, and then change its sign. So what that looks like is, since we have, say, 2 to the negative 2 down here, we can move this to be 2 to the positive 2, but in the numerator instead. So we're going to get 2 squared in the numerator, and then we can move all of the factors up here that have negative exponents. We can move them down into the denominator and change the sign of their exponents. So we're going to get 3 to the positive 2. We'll get m squared now positive to the positive 2, and then n to the 8th also to the positive 2. And the rest of this is just simplification. So it gets 2 squared is 4. In the denominator, 3 squared is 9. M squared will be m to the 2 times 2, which is m to the 4th. And then n to the 8th squared will be n to the 8 times 2, which is 16. Here's our final example. So what I'm going to do now is we have these, you might say, okay, well, we have this negative exponent in here in the parentheses. Can we simplify that? There's something we could do here, but the easiest thing to do here is just going to apply this second power to each factor. So let's do that first. So we get here this 5, we can just leave it alone. We're going to get 3 squared, c squared, and then d to the negative 4th squared. Okay. Now we can simplify this a bit using the sort of the power property here. We get 5. Okay. We get 3 squared is 9. We still have c squared, and then d to the negative 4 to the second power will be d to the negative 8, right? Because negative 4 times 2 is negative 8. And then the last thing to do, so that we have no negative exponents, will be to just move this into the numerator by changing its sign. So that will give us 5d to the 8th over 9c squared. And that's it for exponent rules. So there's a lot of these rules, as you can see, and they can combine in ways that can be fairly tricky, right? All of these different rules can interact with one another and create relatively complicated problems. This is going to require a lot of practice. So you're going to have to grind these out a little bit, okay? But if you do enough of them, it'll start to click. It'll make a lot of sense. All right, until next time, have fun.